Hi, welcome to your Week 8 video. On this session, we're going to be talking about some insights for architects, engineers, contractors, and facility managers. We will be exploring the emerging trends and directions on the construction industry. The current and future trends in architecture and engineering will be, we have an introduction of these emerging trends, and in this presentation will inform architects, engineers, and other stakeholders about the latest emerging trends and future directions on the respective industries. There are different trends such as sustainable design and green building. Um, the importance of sustainable design is to reduce the environmental impact and improve the occupant health and well-being, and also increase the building resilience. The benefit of green building practices will be the energy and water efficiency, reduced waste and emissions, and improved indoor air quality. These emerging trends in sustainable design also considered biophilic design, net zero energy buildings, and passive housing designs. Innovative green materials and technologies are also another trend, such as green roofs and walls, recycled materials, and energy efficient lighting and HVAC systems. And well, there are different innovative materials and construction techniques that we can mention. One material will be bamboo. Uh, Construction with bamboo, been uh, it's been used for our different architects um, because they provide a renewable source of materials, and it also reduces the carbon footprint. Similar to, well, it's not similar, but it's another material that it's a renewable source, will be the hempcrete, that it's a mix with concrete and hemp. It's also used to reduce the carbon footprint, and their properties for isolation and heat resistance are really good. There are other materials such as mycelium and other bioplastics. We also have another trend on concrete, metal, and plastic 3D printing. This trend allows for a faster and more efficient construction process, the reduce of waste, and increased design flexibility. There are 3D printers for concrete where you can see houses being built in really fast record times, only pouring concrete and printing the house. You can also see different um, metal pieces made on the 3D printer, and also plastics made on 3D printing. We also have concrete with bacteria that can repair cracks, reduce the maintenance costs, and extends the lifespan of the concrete structures. Uh, we also have the graphene, the carbon nanotubes, and other nano-enhanced materials. Then these materials are meant to enhance the strength, durability, and resistance to extreme conditions on different buildings. Another trend will be the prefabricated building components that allowed for a faster and more efficient construction process. Um, you can produce your walls, your foundations, your beams, your columns on a warehouse with the quality standards that you need, and then you can send all those elements to your job site. And by doing this, you will reduce the waste, um, you will increase the design flexibility, and you will reduce cost also, mostly on manpower. We also have the living walls and roofs with vegetation. This is another trend that increases the energy efficiency, improves the air quality of the building, and provides aesthetic benefits for the building. We can see different green walls, and these living walls and roofs with vegetation can provide better comfort for the users on different types of spaces inside of a building. And well, we can see these pictures of these different trends. On the left side, we can see the materials such as the bamboo, these bioplastics. There are also experiments using materials such as the desert sand for construction. And well, we can see the 3D printing of concrete. It's basically making different layers of concrete at different heights, and once we reach certain type of height, we get our wall done, and we can program this to generate windows, to generate doors and different elements to build a house. There are different experiments with concrete, such as this concrete that heals itself, and well, also we have the hempcrete and other types of concretes that are high resistance with graphene and other materials. We have the prefabricated elements such as this wall. So we fabricate this wall on the warehouse and get it to the job site. And we have also buildings with a lot of vegetation on the roofs and on the walls. This is to increase the comfort and aesthetics of the building. This is one trend with AI for design and to improve the algorithms of construction. This is also used for renders and design, generating ideas with 3D models, and creating algorithms to optimize structures. Digital collaboration will be the work on the cloud, building review for the cloud platform can be used on the job site and on the office. Or the printing for materials, plastic, concrete. You can build a house in the 100% concrete printed. With windows, doors, and roofing. The development of robotics and construction is also going to be used. Use of robots for automation, construction, and different tasks also. Robotics are meant for surveying high-risk places in different construction sites. This system also shows how to build walls with this machine, and digital twins, that is the digital representation of the buildings. Well, we're already seeing on this video different trends on construction. And now we're going to talk about these trends. We can start with the digital twins. As I already showed you, the digital twin, it's a virtual representation of the physical asset that uses real-time data to mirror the asset's behavior. This technology is increasingly being used in the AEC industry to create more accurate data-driven BIM and CAM models to enhance collaboration, also construction efficiency, and it's also being used for facility management. Digital twins can be made for buildings, for industrial plants, dams, or any infrastructure that you can have. This is meant to analyze how the building will perform, and you can also do energy analysis, coordinate different tasks, and etc. The definition of a digital twin will be that it's a digital replica of the physical asset, also the process and the systems that are used in real time to mirror and predict the asset's behavior. This is done by collecting and analyzing the data, and also digital twins enable better decision making, monitoring, and optimization. What we're seeing on this picture is a point cloud of different pipes and certain type of sector of an industrial plant. Usually we use point clouds to generate the digital twin, since we have a 3D picture of all the equipment and all the elements that the point cloud cover, and that way we can develop our digital twin. We can integrate BIM models with CAM elements with digital twins to create the more accurate data-driven models, and this will allow the stakeholders to visualize the building or infrastructure project in its entirety and simulate its behavior under different conditions. By connecting BIM and CAM models with real-world data, digital twins facilitate more accurate construction planning, fabrication, and assembly. Digital twins can help also to identify inefficiencies and bottlenecks in the construction process. This can allow teams to make adjustments that improve the overall construction efficiency. By providing real-time feedback, digital twins enable teams to optimize the use of resources, also reduce waste, and minimize delays on the schedule. Once a project is completed, digital twins can continue to provide valuable insights for facility management and maintenance. Facility facility managers can use and monitor the performance of the building systems and components of the different equipment. And the digital twin can help to identify the maintenance needs, predict equipment failures, and optimize the energy consumption. This ultimately leads to reduced operational costs and improved sustainability. Well, the rise of virtual and augmented reality for applications in architecture and engineering will be, well, virtual reality is mostly used for design and visualization. This will be around 35% of the use of virtual reality. Augmented reality used for construction site planning, it's on a 25%. Virtual reality collaboration for global teams will be 15%, and augmented reality maintenance for maintenance and repairs assistance is used on 10% of the projects, and virtual reality on training and simulation, it's also 10% on different projects, and other tools are 5%. Now let's go ahead and talk about robotics in construction to explore the impact of automation and robotics on the construction industry, the current state of construction automation, an overview of the current state of automation and robotics technology in construction will be that well, there are different robots and different tools that are robotics program technology used in construction. There are different benefits on robotics in construction. There are also different types of construction robots, from a robot dog, from a humanoid, from a little remote car that draws your drawing on the job site. And also there are different challenges and limitations. One of them will be the cost, the maintenance, and the regulatory barriers. And well, the future, we're going to see the future of construction in automation, including the potential impact on the job roles and the industry practices. Well, here are different pictures of different examples of robots. The first one will be the Unitree Go2 robot, that it's a quadruped or a dog that it's mostly used to control and survey your construction project. Similar to this robotic dog, we have the Boston Dynamics, that will be another dog with different features, well, similar features actually, used for control the job site and walk around the project. We have the control of project using drones also. On the lower left side, we can see Dusty Robotics, that it's a company that develops this printing robot that will print your layout on your construction site. This is mostly used for drywall constructions and indoor elements where you want to print your project, and this robot will make different lines and will actually outline the walls and the elements in the floor, so you're going to know exactly where you're going to place your construction. And on the right, we can see this camera that is controlling a certain type of work on this crew, and it can identify how many workers you have on the job site, what is the equipment they're using, and this will generate data, so you can generate reports on the office. Now what I'm doing is I'm going to the web page of Unitree. That it's a Chinese company that is developing this type of robots, this humanoid robot, and also the robot dog. Well, these tools come on different options. This will be the most powerful robot dog, and this will be another type of robot. What it does, it has a 3D scanner, a point cloud, a LiDAR scanner, where you can use this on your construction site. This robot dog has also capability of carrying around 13 kilograms of anything that you want to carry. And also you have this humanoid that will be an assistant for different types of works. So if you want to see more detail about this quadruped, you can get inside this web page and check out all the benefits of this robot dog, and also the humanoid that Unitree is developing. The good thing about this robot dog will be the price. This robot dog, it's on an affordable price. I think one of those, this Unitree Go 2, it's around $2,000, $3,000. So sometimes it's affordable for some people, and well, you can use it on your construction site. Another company that this time it's an American company will be this robotic dog, and this that is called the Spot. This is the most robust dog and also more expensive. I believe this dog it's around $5,000. If I'm not correct, I think it's a little bit more. And well, this dog is meant to, it's also similar to the Unitree dog, where you can attach to the dog, to the upper side of the dog, different laser scans, different tools to control your project. Boston Dynamics has also different automation tools, such as this robotic arm. And they are developing different applications, and mostly they are using this for research. They are not selling this much outside the US. This is mostly for the US. They have this politic that they don't share this a lot outside the US. But this tool is being used for inspection, site management, safety and response, research and development, and well, different industries. This is another robot that's called Atlas. Well, it has different capabilities, and well, I encourage you to get inside this page and navigate if you want more detail about all these tools that Boston Dynamics is offering. Now, well, I already mentioned this little robot that will print your digital model directly on the job site, in the job site floor, and will automate the layout of your design and streamline the beam to field process. So as you can see, this little robot will draw all the elements on the job site, and you just have to program and control this so it can be as accurate as possible. This is the web page where they show all the detail of this robot. So you have the design, and the robot would outline all these elements so you can construct all these walls and also HVAC systems or any detail that you want to show on your project. Well, what they offer is 10 times faster layouts, accuracy, native model coordination. You can coordinate with the BIM model in one place and with the native Autodesk Revit and AutoCAD integrations, and your model will be visualized before the construction starts. Well, these are some examples where this robot was being used, and this is a little video. If you want to learn more, you can also get inside this web page and see more detail about this little robot. And we're going to see also the future directions on facility management. That it's mostly the use of smart buildings and the Internet of Things. That they add mostly a lot of sensors and different tools to control the lighting, to control the HVAC systems, the security systems, and other systems that may be on the building. So if we see this pie chart, there are different different uses, the percentage of uses of most commonly uses. We have 35% for HVAC systems used for smart buildings. There are a lot of sensors for HVAC systems to control this. We have a 25% of this Internet of Things systems and sensors for lighting systems. We have a 20% for security systems and 10% for energy management and another 10% for others. Well, and BIM models are an important part on facility management. Well, this is being used for different ASC contractors and stakeholders. Since the BIM models have a lot of information inside, it can help the designers, the owners, and also the users of the different buildings. It also will help for a more efficient and more accurate data management. And also for maintenance and operations, you can monitor and manage the assets to automate and maintenance schedules, reduce downtimes, and have a more effective operation. Now, if we can analyze and highlight the importance of energy management and efficiency in facility management, we have the energy management systems and how we can improve the energy efficiency approximately by 20 or 30%. We have renewable energy sources. By using this type of energy sources, we can reduce the reliance of fossil fuels and decrease the carbon footprint. We can also have energy audits and benchmarking by identifying the areas for improvement and tracking progress. We also can manage the energy by building automation and controls. We can improve 20 to 30% just by optimizing the energy usage and reducing waste. And we have the occupant behavior modification. We can encourage for a sustainable practice among the building occupants. That's another option. It's not related with the building, but usually when you take care of all this waste and all the different sustainable practices, you can improve the energy efficiency just by turning off a light bulb. Now it is possible to control using a digital twin our assets, see the performance, how much energy of consumption. Also, if we have a plumbing system, we can calculate how much water we're using, and if we have the sensors, we can control different types of systems. Now let's continue watching this video um, about more game-changing construction trends from IoT to digital twins. We can see here some guy using VR goggles to visualize different construction element. So let's take a look this video.
Welcome to our weekly BIM update. Latest trends. Today we're diving into 3 game-changing developments in the BIM world for 2024. First up, let's talk about the integration of IoT and BIM. The convergence of Internet of Things technology with building information modeling is revolutionizing how we manage and monitor construction projects. IoT sensors embedded in buildings provide real-time data on various parameters, enhancing decision-making and predictive maintenance. According to a recent article by United BIM, IoT integration not only improves operational efficiency, but also enhances safety by allowing for proactive identification of potential issues before they become critical. Next, we're looking at how cloud-based BIM and advanced technologies like AR, VR, and drones are transforming the construction landscape. Cloud-based BIM platforms facilitate seamless collaboration among project stakeholders, regardless of their physical location. An insightful piece by Pinnacle Executive highlights that the use of AR and VR in construction not only improves visualization, but also reduces errors. Meanwhile, drones are being increasingly used for site monitoring, providing real-time updates and enhancing project oversight. Lastly, let's explore the role of generative design in modern construction. Digital twins, virtual replicas of physical assets, are becoming crucial in lifecycle management by simulating different scenarios. Digital twins help optimize. As noted by BI community, generative design leads artificial intelligence optimized based on. It not only accelerates these advancements in IoT integration, cloud-based BIM, digital twins are just a few examples of how technology is driving the transformation in construction. For more in-depth insights, check out the articles from Construction Placements, Pinnacle.ut. Stay tuned for more updates. Don't forget to subscribe for the latest.
Let's talk about now artificial intelligence, or AI, and machine learning. AI and machine learning algorithms are being incorporated into BIM and CAD software to automate and optimize different processes such as design analysis, the material selections, manufacturing planning, and others. This will allow for quicker and more informed decision making and increased efficiency. The definition of AI refers to the development of computer systems that can perform tasks typically requiring human intelligence. This can be problem solving, some pattern recognition, and learning from those data. Machine learning is a subset of AI that focuses on developing algorithms that can learn from and make predictions or decisions based on data. So if we found some patterns on our job site, what AI or machine learning can do is to optimize different processes that are being used on our job site. AI and machine learning algorithms can be used to analyze BIM models, identify potential design issues, or areas of improvement. This automated analysis can quickly detect and suggest solutions for problems such as structural weakness, energy inefficiencies, or building code violations. About manufacturing planning, in the context of CAM, AI and machine learning can be used to optimize manufacturing processes such as toolpath generation, machine parameters, and machine scheduling. By analyzing historical data and learning from past experiences, AI can automatically adjust and optimize these processes for increased efficiency and reduced waste. AI and machine learning can provide valuable decision-making support for architects, engineers, and construction professionals. By analyzing large data sets, identifying patterns, and making predictions, AI can help inform for a better design and construction decisions, ultimately leading for a more efficient and sustainable project. As AI and machine learning algorithms continue to learn from the new data and experiences, they can adapt and improve their performance over time. This enables BIM and CAM software to become more intelligent and effective, continually enhancing the efficiency and quality of design and construction processes. AR and VR technologies are being used also to visualize BIM models and CAM processes in a more immersive, interactive manner. This enables a better communication, understanding, and decision making among stakeholders. By using AR and VR tools, we can visualize um, different construction designs and also different CAM processes and simulations. And what is the definition of AR on VR? Augmented reality is a technology that overlays the digital information or graphics into the user's view of the real world. While virtual reality, it's a fully immersive computer-generated environment that users can interact with using specialized equipment. The visualization for big models um, with AR and VR technologies, um, they can provide an enhanced visualization for big models. This can allow stakeholders for a better understanding of the design and spatial relationships within the building. By experiencing the design in a more immersive three-dimensional environment, the stakeholders can make more informed decisions regarding the space planning, construction methods, and material selections. To visualize BIM models with AR and VR technologies, we definitely need the equipment such as VR goggles, or also there are different types of AR goggles where we can visualize purely the 3D model on an immersive space, or we can see it and project on the real world our project with AR. And well, we can also do virtual walkthroughs with VR tools. This will enable architects, engineers, and clients to conduct virtual walkthroughs of a building before it is constructed. This can help identify potential design issues, improve the communication between the stakeholders, and provide a better understanding of the end user experience. If we are on the job site and we need on-site construction support, AR can be used to overlay the BIM data into the physical construction site using digital tools such as a tablet or maybe a mobile phone. This will provide real-time information to construction professionals, and this can help with accurate positioning of the building elements, identifications of deviations from the design, and verification of the complete work. Collaboration and coordination platforms are used also for AR and VR technologies, and this can facilitate collaboration and coordination among the BIM and CAM stakeholders by providing a shared and interactive environment for receiving designs and discussing the project details. This can lead into more efficient decision making, reduce errors, and improve the project outcomes. Also, the use of cloud-based BIM and CAM platforms can facilitate to improve the collaboration, the data accessibility, and real-time updates by hosting BIM and CAM data on remote servers accessible from anywhere. Now, well, there is also space for research and development opportunities. One development and research opportunity will be the interoperability and data exchange standards. This is something to continue on the research because sometimes different softwares need to enhance the interoperability between the BIM and CAM software, as well as to develop new data exchange standards that facilitate seamless integration. The only standard that exists is the IFC standard, but it does not match completely with sometimes with CAM softwares. So that's why it's a field for research. Another research topic will be automation and optimization. Researching into AI, machine learning, and optimization algorithms can lead for a better development of new tools and techniques for automating and optimizing BIM and CAM processes. This will result in increased efficiency and reduced costs. What we can do is to apply all these techniques of AI and machine learning into our project and see the metrics of how we can increase the efficiency and calculate the efficiency and analyze what are the benefits of using these tools into our job site or project. We can also investigate how BIM CAM integration can be used to optimize the sustainability and the environmental impacts on construction projects. This can lead to the development of new green building practices and technologies. This is mostly focused on the design of different elements so we can be more sustainable and optimize our building. And well, we're coming to the end of this video. We're going to see a course summary, and also I would recommend to you as a practice to develop a final project presentation. You can choose whether a BIM model or a CAM model, so you can show it to the class. About the final project presentation, you will find more detail on the course information, where you can continue your research and develop your project, your personal project, to present it to at the end of this class. And well, if we can do a recap of the key concepts on this final week of the course, the key concepts and principles for BIM-CAM integration, collaboration, and coordination will be reviewed. First of all, you have to remember that BIM models are used on all the phases of a construction project, going from the design, from the execution, and also on facility management and closing. And BIM models include all the disciplines inside the model. This is called usually a digital twin when it's an exact copy of the real building. And well, if we talk about CAM, CAM models are also a part of BIM models, but are mostly used for fabrication of parts, different pieces. And well, on this course, we talked about all the different machines, the CNC machines, the laser cut machines, how the tool paths were generated, and the different types of tool paths, the different types of details, the different software that we used to generate, to cut a certain type of piece or to develop certain type of element. We also saw the simulation on CAM models and how we can program with the different tools that we have, the shapes to make certain type of cuts on fabrication. And well, finally, we've seen all the future trends on construction, mostly the collaboration cloud, the BIM models, the different robotics elements that can be used on different job sites to control the construction project, the use of AI in construction, and also the integration with facility management and the integration with CAM models. So this will be all for my part. If you have any questions, please let me know. If you want to try to implement a sustainable design or using innovative materials, embrace virtual and augmented reality, adopt different automation and robotic tools, and integrate smart buildings and IoT tools using BIMs for facility management. You can leverage data analytics. Well, and this will be all for my part. If you have any questions, please let me know. You can go ahead and try to implement all these tools that we've seen, the use of BIM for facility management, the use of integrated smart buildings and IoT tools, the use of automation and robotics. Go ahead and practice all this theory that I shared with you. This will be crucial to increase the efficiency and stay ahead of the game in the future of architecture, engineering, construction, and also facility management. This will be all for my part, and see you on the next opportunity. Thank you very much.